Here's a breakdown for Chapter 2 test. So number 1 and 2 would be similar to page 63, number 7 through 24. Number 3 and 4 on the test would be similar to page 63, 29 through 32, 37 through 38. Number 5 through 8 on the test would be similar to page 81, number 1 through 20, and 57 through 60. Number 9 and 10 on the test would be similar to page 110, number 1 through 12. And number 11 through 17 on the test would be similar to page 110, 13 through 20, 41 through 44, 57 through 60. And you also need to know the unit circle. So the unit circle is this handout right over here. So on the test, you will be given a blank sheet of circle, and you need to you have to duplicate these. So you have to fill all the numbers. So make sure you practice with the circle. So you need to fill exactly like this. So again, you're going to get a blank circle, and you have to fill in. You have to duplicate this chart over here. Okay, so that's a unit circle. So make sure you study this well. Again, this is based on a spatial triangle. Okay, so now let's go and review. Okay, let's go to. Let's start with page 63. And let's go to 17. So for number 17, you have pi over 60 radian. And you want to find a degree measure. So let's go and find a degree measure. And the way to convert that is you convert into degrees, so you put degrees on top, so times by 180 over pi. And so this cancel out, and this cancel out. And so it'd be 3. So this would be 3 degrees. Okay. Let's do number 23. Number 23, you have negative 7 pi over 3 radian. And you want to sketch in the standard position, and so you need to figure out where that is, okay? And you can go, this negative is going backward, right? So 7 pi over 3, so this is negative 1 pi over 3, negative 2 pi over 3, negative 3, negative 4, negative 5, negative 6, negative 7 pi over 3, okay? So this is, again, negative pi over 3, negative 2 pi over 3, so you have to know your position. So 1, 2, 3, 4, 5, 6, 7. So it's going to be right over here. And then over here, so you sketch that, and this would be your pi over 3, right? This is your alpha. Okay. So make sure you know how to draw these. Okay, let's go to number 31. Number 31 is in a circle of radius 7, so you have a circle, radius of 7 meters. Find the length of the arc, so you're looking for the arc, subtended by the central angle of theta equal to 1 point. Okay, I'm going to do it on the side over here because I need to do multiple parts. So for part A, theta equal to 1.35 radian. And looking for the arc length. You can remember this is the review from previous test, right? So S equal to 2 pi r, that's the entire circle, times it by the fraction, so theta over, now this is radian, so it would be over 2 pi, right? If it's degree, you would be over 360. So this is radian, you have to use over 2 pi. And this will cancel out, then you substitute, so S equal to 1.35, and, radius is 7. So radius is 7 meters, and theta is 1.35. So S equal to, and you get calculator and you multiply out. So 7 times 1.35 equal, you got 9.45, and the measurement is meters. Okay. And I'm going to do B. For part B, your theta equal to 42.0 degrees, Okay, so you can again write the formula S equal to 2 pi r. That's the whole circle, and you times it by, now you times by the fraction that you want. So you got 42.0 degree over 360 degrees. Okay. So you can, if it's radian, use over 2 pi. If it's degree, you have to use 360, right? So now you go and substitute. So S equal to 2 pi r equal to 7 meters times by 42 over 360. Right? The degree cancel out already. So get your calculator. So 2 times pi times 7 times 42 divided by 360 equal, so S equal to 5.13 meters. Okay, now let's go to number 37. Number 37, again you have the circle, but this time you have you're looking for the sector. It's in a circle radius of 12.0 centimeters. Looking for the area of the sector with, so A, central angle, the theta equal to 2.00 radian. So the area, now this is a circle, right? And area is going to be pi r squared. Okay, so make sure you don't get confused, right? Again, the length is a circumference, the length is 2 pi r. The area is pi r squared, and again, you times it by the theta over, now this is radians, so you have to use 2 pi. Okay. So now you substitute, so area equal to pi, and I'm going to write it out, so it's easier for me to multiply, and I have a 2 over 2 pi. So these two cancel out, the pi cancel out, so area equal to 144, and the unit would be centimeter square, right? It's square, so make sure you have that square. Okay, now let's go and do B. B is when theta equal to 25.0 degrees. So again, area equal to pi r squared times theta over 360 degrees, right? Because degrees we have to use 360. So you always write down your formula, then you substitute. So it would be pi, radius is 12. Again, I'm writing it out. Theta is 25 over 360. So get a calculator. So pi times 12 times 12 times 25 divided by 360 equal, so area equal to 31.4 centimeter square. Okay. Okay, let's go to page 81. And let's do number 17. Page 82. 17. You have sine theta equal to -7 over 25, and this is a quadrant 3 angle. And you're looking for the 6 trigonometric ratios. So again, first go and draw triangles. Okay, so quadrant 3, right? And then sine is -7 over 25, so -7 over 25. Use your Pythagorean theorem or use your spatial triangles. This would be 24, and it's going to be negative. Okay. So once you get it over here, then you get your ratio. So you got sine theta. It's already given, but go and write it again. So sine, cosine. So cosine is horizontal over hypotenuse. And tangent. Tangent is sine over cosine, so it would be -7 over -7 over -24. So this will equal to 7 over 24. So once you get a 3, you get the other 3. So sine, you get cosecant. It will be 25 over 7 negative. Okay, and then you get secant. It would be -25 over 24. And then cotangent, you flip this over, so you get 24 over 7. Okay, let's go to number 43. Okay, number 43, you have, now instead of giving you the ratio and the quadrant, they give you the point. So 1, negative square root of 3. So you can, every problem is the same steps. You got to get your triangle. Okay, so this is going to be 1. Now this is longer, so just again, so if this is longer, just make it longer than that, right? So it'll be 1, negative square root of 3, so this will be a 2. So once you do that, now you can go and get your function, right? Sine, cosine, tangent, right? So sine is the vertical over hypotenuse, so it would be negative square root of 3 over 2. Cosine is this over this, would be 1/2. Tangent is sine over cosine, so it would be negative square root of 3 over 1, which will give you negative square root of 3. Then after that, you can get your cosecant. You flip it over, so you get negative 2 over square root of 3. Okay. Now, if you leave it like that, that's fine. But you should be able to simplify that. Okay. Then after that, you get secant. You go to 2 over 1, and then cotangent theta. Now, don't flip this one over. Okay. Okay. Let's just flip this over. So you got negative 1 over square root of 3. Okay. Now, since in the book did not simplify, I'm going to just allow you to do that. But you should simplify this into, normally you want to simplify. Okay. Okay, now let's go to 57. Okay, 57, you have sine theta equal to 1/2, and tangent theta is less than 0. So you have to use this information, right? So again, you got to locate your triangle. Tangent is a slope. So slope is less than 0, means slope is negative. That means it's going this way. Okay? So again, you got 4 quadrants, you narrow down to 2. Now you have to use this information. Sine is vertical, so vertical is positive. Okay, so this is the wrong one. So this is the one. Okay, so it'd be 1 over 2. So this would be square root of 3, right? That's your spatial triangle, and it's negative. So from here you can get sine, cosine, tangent. Right? Sine is this over that. Right? So sine is 1 over 2. Cosine is this, would be negative square root of 3 over 2. Tangent is sine over cosine, so it would be 1 over negative square root of 3. Okay, sine. So again, I'm going to allow you to do that. Okay, sine, and then you get cosecant. You flip it over, you get 2, and then you got secant. You flip it over, so it would be negative 2 over square root of 3. And cotangent, you flip it over, you get negative square root of 3. Okay. Okay, let's go to 59. Okay, number 59, you got secant theta equal to 3 over 2, and you got sine theta is less than 0. Okay, so sine is vertical, and vertical is less than 0 means negative, so you're going to get these 2 over here. Right? From this, you get that. Now, secant came from cosine, so cosine is positive, so it's this one here. Right? Again, secant came from cosine, and cosine is positive, so it'd be this one. So it'd be 3 over 2, so it'd be 3 over 2. Right? Secant came from cosine. And so from here, use your Pythagorean theorem. So this would be square root of 5, and it's going to be negative. So sine theta equal to this, so it would be negative square root of 5 over 3. Okay, cosine theta is this over here, would be 2 over 3. And tangent theta equal to sine over cosine, so it would be negative square root of 5 over 2. Right? Again, you use your functions. Then you're going to get cosecant. Cosecant, you just flip this over, so it would be 3 over negative square root of 5. And then you get secant, flip it over, and you got cotangent, you flip it over. Okay, let's go to page 110, number 5. Okay, number 5, you have theta equal to negative pi over 3, and you're looking for reference angle. So you draw your triangle. So negative pi over 3 is right over here. That's your negative pi over 3. Now, reference angle is this angle right over here. So alpha, in this case, will be pi over 3. Okay. So your reference angle is always positive, and it's always this angle over here. Okay, let's go to number 35. Number 35, you have secant of negative 3 pi over 2, and you're looking for exact value of these. So all these, you need to go and get your triangle. So negative 3 pi over 2, so from here you get negative 1 pi over 2, negative 2 pi over 2, negative 3 pi over 2, so it's right over here, okay? And this coordinate would be 0, comma 1, right? So, and radius is equal to 1. So secant, so secant equal to 1 over cosine, right? So in this case, the cosine theta, okay, on this one, cosine. So cosine is going to be 0 over 1, right? 0 over 1. So the secant of the theta, secant of negative 3 pi over 2, is going to be flipped over, so it be equal to 1 over 0. So this is undefined. Okay. Let's go to number 39. Okay, number 39, you're looking for cotangent of 405 degrees. So in this case, what you do is you can go and use a coterminal. You can minus 360 to lower your angle, so you got cotangent of 45 degrees. So that one's kind of easy, right? So now it's a lot easier to do. So you're going to get 1 square root of 2, right? Now cotangent is cosine over sine. So this is going to be equal to 1 over 1, which is equal to 1. Okay. So the key is go and locate your angle so you can draw your triangle, label 3 sides, and apply your function. Okay, let's go to number 41. Yeah, cosecant of negative 495 degrees. So you can apply your coterminal. So you plot 360. So it becomes cosecant of negative 135 degrees. Now, if you still don't know what way that is, then you can go and apply. You can go and keep adding. You can plot 360 again if you want to. Okay, so you becomes cosecant of positive 225 degrees. Okay, so when you apply that, you get 180 degrees over here. So this is going to be a 45-45 spatial triangle. So you're going to get negative 1 square root of 2. Okay, so cosecant came from sine, right? So sine of 225, by looking at that, sine of 225 is this over that, so it would be negative 1 over square root of 2. Therefore, cosecant of 225 will equal to, flip it over, give you negative square root of 2. So sometimes it is easier to use the sine, cosine, tangent, and then do the flipping up to that. But all these kind of problems, first you have to locate your angle, then draw your triangle, get all 3 sides, and then you apply your function, apply your ratio. Okay. And again, after this, remember that you were giving a blank circle and you have to duplicate the chart. So you have to know all the coordinates and all the positions. So like this over here, you have to know that this is a 5 pi over 6, and the x, so this is the x, this is the y, right? So x would be negative square root of 3 over 2, and the y would be 1/2. So make sure you can duplicate this circle. Okay. So again, this is all based on the spatial triangles.